also part of a co-ed engineering fraternity. It's called Theta Tau. We're relatively new at Cal State Fullerton. And even though this semester is going to be virtual and online, we're still going to have Rush. So if you guys would be interested in being involved, you guys can rush for us next week, starting September 7th, September 7th to September 10th. And all the meetings start at 6 p.m. It'll be on Zoom. And I have one of my brothers here too in this class. So Joshua, if you want to speak.
Hi guys, so as you know, my name is Joshua. I'm part of Theta Tau. I'm also part of the alumni chair community. And for me, as a transfer student, I really wanted to get in depth with as an engineer field. So yeah, pretty much Fabio is summed it up pretty well with who we are, and we're pretty new. If you guys want, I can give you information on Discord, if that would be all right with the professor.
Yeah, that's fine.
All right, cool.
I will also, on the chat right now, I'll put a couple of links and the Instagram account. So that's the CSUF Theta Tau Instagram and the link, and then Rush that starts next week. Yeah, so basically we're a professional co-ed engineering fraternity, and it's for like all engineering computer science majors. So if you're interested, you can follow on Instagram and read what it says. Yeah, if you have any questions, you can DM on Instagram. And there's basically a bunch of different positions you can do after being in. And so when I first started as a pledge, I was fundraising chair. Then when I became active, I was public relations. So, and then if you guys want to work on projects too, we have that too. This semester for projects is going to be a little bit different because we are virtual. So it's mainly going to be you doing your own little projects at home. But last year and every year we do the pumpkin launch at school. I don't know if you know that, but it's basically when you're either in a club or an organization and you build some sort of pumpkin launcher, and then you just launch pumpkins at targets. So that's pretty fun. And then we also created our own competition called the Beta Bots, or well, the Theta Tau bots. So we basically made little robots to compete against each other. I don't know if you've heard of that, but if you were in other clubs, we invited them to compete against us. So if you have any questions, you can ask now, or you can just follow on the Instagram account and ask there.
Anyone have any questions? Okay, well, thank you. So yeah, you guys can look at the Instagram, or you can go in Discord too if you have questions.
Thank you.
All right, so we'll get started today. Let me change this real quick. All right. So first of all, let me share my screen. Okay, so first thing we're going to talk about today, I updated the Canvas website again. So chapter 1 homework, I think I posted that on Monday night. So that's going to be due this coming Monday, that's September 7th. And right now I have this, I've had a few questions on how to turn in the homework. So if we're on the homepage for the course, we're going to go to week 2, or you can just go to assignments. So let me change the view. All right, so you can just click on assignments on this left sidebar here. And right now you're going to see, so quiz 1 that shows up right now, but you can't access it. I'll talk about that in a second. But click on homework 1, intro to MATLAB. And okay, so I have this submit your own homework in the text field below. So you'll see if you click on submit assignment, And to label each question, you know, question 1, basic math, and then I have kind of sub questions. And you're just going to type out the code. You're not going to submit a MATLAB file. So just type out the code and type out your response here for the MATLAB comprehension questions. And then I'm going to post the solutions on Tuesday. So if I go to submit assignment, then you see this text box. This comes up. And so this isn't really a good method right now. I know it's kind of bad, basically. I don't want you to submit a PDF though, because I don't want to have to basically download 42 PDFs. It'd be easier for me to grade if it's just online. But I'm trying to change this, and I don't know if I'll get it done before the first homework is due, but I want it to be where there is one question and then a text box below for that question, and all you have to do is just type in your answer. So I think I know a way to do that. Basically, I have to pretend that this homework assignment is a quiz. So that's just for formatting now. So I'm going to try to get that done, but as of now, you actually need to type in everything in this text box. So just do basic math. Let me open up the homework here.
Do you want us to wait to submit until you figure that out, or?
Up to you. I would allow you to submit it right now. And if I change the format, then that should still be fine. You know what? Actually, I will have you hold off. I'm going to try to do this right after class. Okay, I'll send out an announcement to you. So don't send in the homework until tomorrow if you're already done. So appending vectors, I'm going to talk about that today.
So still do the homework, but just wait on submitting it.
Yeah. Sorry for the confusion, but I want to fix this formatting because it's kind of weird right now.
Okay.
All right, so yeah, I'm gonna work on this right after class, so it's better for you, and you can start submitting tomorrow. But I'm gonna send out an email so you know. Okay, and I want to see so far. Here, let me go back to Zoom. Okay, I'm gonna try to add a poll here. So I'm gonna add a poll for those of you that have worked on the homework so far for how hard it is, or you can just put it in the chat, I guess. I'm gonna make a poll. All right, so you should see a poll up right now for how the homework is so far. So tell me if it's hard, if it's not bad, or if it's too easy for those of you that have worked on it. Okay, not bad. One person says too easy. Okay. Okay, so yeah, I want to make the homework, at least somewhat challenging, but I also don't want it to be too hard, and I don't want it to be too easy either. So, no one said hard, so I guess that's good. I don't want to start out too hard in the beginning here. Okay. But anyways, if you have questions on the homework, ask in the Discord, or you can send me an email, something like that. And then one more thing I want to go over is the quiz format. So let me share my screen again. Okay, so for the quiz, I'm going to go to quizzes here, and you can do this as well. So you're going to see this right now. You can't actually access the quiz. And the quiz, again, that's next Wednesday, September 9th. Right now, I have it scheduled for 11 a.m., so it'll be a 15-minute quiz. So from 11 a.m. to 11:15, it's going to be on Canvas. So for this, it's going to be a better format. Let me leave student view. Now you can see the quiz. Now I got to change those questions. I thought that might happen. Okay, so this is a random one now. Okay, So this isn't going to be a question, but this is going to be the format that you see for the quiz. So this is how I want the homework to look too. So it's going to have a question here. This is question 1. And then you would just go in the text box. Let me go to preview. Okay, so here's the question, and then you would just type your answer in this text box here. So for this, we'll do something like x equals 0 to 0.01, then to 20. So that's going to create a row vector from 0 to 20 with a step size of 0.01, and then you would just submit it. And you see up here, it shows the time remaining is 15 minutes right now. I'm planning on the quiz being 15 minutes. So you'll have enough time to do everything. And, you shouldn't feel rushed, but I don't want it to be a really long time to take the quiz, because then there might be some sharing of answers, and I want you to work on it by yourself. Okay, any question on the quiz or the homework? All right. And also, and I'll put this in my email, but remember that this coming Monday, there's no class, so don't show up. Be by yourself.
Professor, quick question. Was the homework due next Wednesday, the same as the quiz, or was it due Monday?
The homework is due on Monday.
Okay, thank you.
And then I'll post the solutions on Tuesday. All right, so today we're going to go over chapter 1. We're going to finish that up. So we'll talk about basically intro to plotting, and then we're going to start chapter 2, which is just going to be on arrays. The quiz is only going to be on chapter 1 though. It's going to be through plotting. So everything that we covered today or up to today for chapter 1. All right. So open up MATLAB. So you can follow along here. Okay. Okay, so the first thing we're going to do is talk about some of the review from last time. So last time we went over complex numbers, arrays and their construction. So the basic construction, like making a row vector, making a column vector, and making very basic matrices. Then we talked about some operations for the arrays and then polynomials. So today we're going to talk about intro to plotting, appending arrays, the transpose operation, array addressing, and then some array manipulation. So a lot of the stuff we're going to talk about today you will need for the homework. So if you couldn't do some problems right now in the homework, you should after today's lecture. Okay, so we're going to start out with an exercise. I want you to define these two vectors here. So we have a row vector, A equals all of that, and then a column vector, B. So I'll give you a minute or so to work on this. Okay, so hopefully you're done with that. So to create a row vector, remember we can do this in a few different ways. We can do it like you see on the slides there. So 2, 0, -3, -202, and then 9. And in this case, I don't have any commas, so that's fine. But I could have defined that same row vector by using a comma after each value, and then we'd get the same row vector. For the column vector B, if we want a new entry in that column vector, we have to use a semicolon. So we'll do b equals 9, semicolon 2, semicolon minus 20, and 400, and then 23. And then again, I could put a space in between or after each semicolon, and that's fine. All right, so hopefully that's basic review for you. Okay, so there's another exercise here. So you're going to create a vector x from minus 20 to 20 with a step size of 0.1. Then after that, define a variable that's called length, and then use the length command to find the length of that vector x. And then you're going to create a vector y from negative 30 to negative 90 with a length of 545. All right, so I don't know if everyone's done or not. It's really hard for me to gauge that, but I'm gonna show you what to do in case you're done. Okay, so for the first one, we wanted to make a vector from negative 20 to 20. And since we know the step size, we can use our operation where we use a colon. So we can do x equals negative 20. And we're going to put in a step size of 0.1. And then we want to go to 20. So there's our row vector. And if I was going to type in x to look at the output, then I see that it's 401 elements long. So that's the length, 401. Just clear that. So to do the length of x, all we have to do is do length equals length of x, and then we get 401, which is what we just saw. Okay, and then for the next one, we're creating a vector y from negative 30 to negative 90, and whose length is 545. So in this case, if you don't want to actually figure out yourself what that step size is, you can just use the linspace command. So we'll do y equals linspace. We're starting, oh, I have an error there, of course, but we're going from negative 30 to 90, and then we want to have a length of 545. I should have suppressed that. But
So it says negative 9.
okay, yeah. Either way, I just want to show you this function. So there we go. And then if I type length of y, interesting. Okay, so you do get an error there, huh? Okay, so I guess it doesn't like that. So if I was going to do just y equals linspace of negative 30 to 90 like I first had, and then let me clear that, and then we did the length of y. Okay, so something's wrong here. Maybe it's because I have length as a variable. Yeah, I'm guessing that's why. Yeah, that's why. Okay, so I was getting that error because I had a variable that was called length. And so there's a question, what is linspace used for again? So let me clear everything. So linspace, that's going to be used if we want to create some vector, and you know the starting point for that vector, and you know the end point for that vector, but you don't know the step size. So if I want to go to start, I'll do another one. If I know that I want to make a vector that starts at 10, and then I want to go to like 223, I don't know, and I know that I want to have a length for that vector of, let's say, 200, I might not know the step size off the top of my head, or I don't want to compute it. So I can use the linspace command. So I'm creating a vector from 10 to 223 with a length of 200. And if I do length of x, we'll see that that length is 200. Does that make sense? Okay. All right, so we got, I think, just one more question here. I want you to generate this polynomial and then find its roots. All right, so I'm just going to call this polynomial p. So I'll do p equals, and then to make a polynomial, all we have to do is define a row vector. So we're going to do 6, 4, 3, and then 1. And now I can find the roots by using the roots function. So just roots of p, and then that's going to give us the roots for that polynomial. And then a refresher, the roots of a polynomial, that's when that function f of x, or in this case, piece of x, equals 0. But this isn't really the main area of focus. I want to focus more on arrays and plotting for the homework and then for the quiz. But you may have a question on this, so make sure you know what to do. All right. Okay, so we're going to start on plotting now, but is there any questions so far on what we've covered for chapter 1? And yeah, we don't need to type out Polly Pocket. So
Yeah.
last time, yeah.
So, we haven't quite gone over to how we should append vectors yet. That was rather early on in the homework.
Yeah, I'm going to talk about that today. That's in chapter 2. So I did say the quiz would cover only chapter 1. So I guess we'll say the first quiz is going to cover everything up till what we covered in today's lecture. So that we're going to start on the beginning of chapter 2, but that's just arrays. Okay, and then so to answer your question, Victor, we don't need to type out Polly Pocket. That was just a variable name that I used before. So last time I did Polly Pocket equals roots of p. Why is it doing this again? Oh, I cleared it, that's why. Okay, so Polly Pocket equals roots of p. So that's the same thing. I just made some variable name called Polly Pocket last time. Yeah, you don't need to type out Polly Pocket. I just made some variable. Doesn't matter. Okay. Any other questions? Okay, so we're gonna go over plotting now. So plotting, it's going to be its own chapter. I think it's chapter 5 in the book, and we're going to go over that probably over the course of a week or 2. I think that's a pretty big thing. You're going to be plotting, all the time when you use MATLAB. So I want to make sure to go in depth with that, but I want to go over plotting, at least the basics right now, so we can actually start plotting some functions inside of MATLAB. Okay, so to make a plot, we're going to need 2 variables. We're going to have an independent variable and then the dependent variable, and they have to be the same length. So if we want to plot, some function like sine of x, that function sine of x, that's going to be the dependent function on that vector x. So we'll see how to make that plot in a bit. Okay, and then, so a lot of the time I'm going to assign variables as x and y. but you know, they don't need to be X and Y, they can be anything. We just need to plot something along the X axis and then something along the Y axis. Okay, so we're gonna plot the function 5 times cosine of 3x. So remember I just said that we need to make sure that our vectors are the same length. So first thing we're gonna do is create a x domain. So we're going to do x equals 0 to 10. And we're going to use a step size of 0.5. And then we'll create our function y equals 5 times cosine of 3x. And make sure that you do 3 times x inside of that parentheses here. Okay, and then all we have to do to plot the function is plot and then x comma y. I'll talk about the other part of this command in just a moment. Okay, so if we plot that, then you're going to get this graph. Ignore that warning sign, that's just specific to my computer. So were all of you able to get this graph?
It's still working.
Okay. Okay. So if you look at this graph, it looks pretty bad. So we're going to fix this in just a moment. So if we look below, in this code, in our X domain, we created a domain from 0 to 10. So we can see the length for that domain if we look in the workspace, or we can do length of X, and then we see that it's 21. So that's just saying that we have 21 data points in this graph. So now I'm going to change the plotting code. So I'm going to do plot x comma y, and then I'm going to do comma, and then in apostrophe here, k0 or o, k0, and then a dash. Now if I plot this, we're going to see these circles, and that's basically representing each data point that we have. So if we were going to count all of these, we'd see that we have 21 data points. So once we get to chapter 5 and we talk about plotting in more depth, we're going to go over how to set a color for a plot, how to have different data markers, which are these circles here. Basically, we could have different data markers like a square, a diamond, a star, stuff like that. And then the dash right there, that just means to use a solid line. So I could also change that to have a double dash, and now we have a dashed line. But again, we're going to get into that once we get to the plotting chapter. So the plot looks pretty bad, so we're going to increase our X domain, the length of it. Okay, so if I do instead of x equals 0 to 10 with a step size of 0.5, if I make that step size smaller, like x equals 0.01 to 10, and then I plot this function. Okay, I need to update y. So you see I got an error there. So I updated the vector x, but I didn't update our vector y yet. Let me clear this. So we have x equals 0 to 10. That's our new X domain. And now I need to run this again. So y equals 5 times cosine of 3 times x. And now if you look in the workspace, they're both the same length. So now I'm going to be able to plot this function. So I'll do plot x comma y, and then I'm going to show you all the data points again. So k, o, and then a dash. Now if I plot this function, now we get something that looks like this. Okay, so this function, or this plot, it's a lot smoother, but it's also still kind of distracting now because we see all of those data points in the plot. So we have so many data points that having those data markers, that's not really giving us any more information that's valuable to us. If we go back to this first graph here, this actually is, it's helpful for us because we see we only had 21 data markers or data points in that graph. So it's useful to see them in the plot. But once we have 1,001 data points, like in this graph here, it's not really helpful anymore. So we're just going to use a solid line. Okay, so we can just change our plot command. So now I'm just going to take out this letter O, and just have a K and then a dash right there. And then we see this plot here, and now this looks pretty good. Also, I can just take out the dash line, because by default, we do have, sorry, not the dash line, just the dash. By default, MATLAB makes a plot with a solid line. And then if I took out the K means black, by the way, then by default, MATLAB plots a solid blue line. But the color and the data points, they're not important right now. All right, any questions on how to make a plot?
I'm still seeing jagged lines on my plots. I don't know if that's...
Okay, and you updated the X domain?
I'm not sure.
Okay, so if you still see a jagged plot, I want you to type out in the command window again to x equals 0 and then 0.01 to 10, just like I just typed out. And then you're going to put in the function for y again. So you're going to type out y equals 5 times cosine of 3 times x. And now if you run the plot command, now you should have a smooth plot. Let me know if that worked.
Yeah, I did. Thank you.
Okay, cool. All right, so we're going to do an exercise now for plotting. Plotting will be a question on the quiz, so I'll just let you know that right now. Again, the quiz will cover everything up to what we covered today. Okay, so you're going to generate an X domain from 0 to 10 with a step size of 0.5, and then you're going to create this function y equals e to the minus x times cosine of 2 pi x. And then you're going to plot it. All right, that took a while, but is everyone done? I made a poll for that. No? Okay, got some saying no. Okay, so I'm going to give you a little bit more time.
Professor, I'm getting a little stuck. So I understand like if I say x equals 0 and then the 2 dots and then 0.5 and 10.
Mm-hmm.
And then for the writing out the code for the y, so I did like y and then exp parentheses negative x, right?
Mm-hmm.
And then the star of cosine. Is it just do I have to write out like cosine and then close parentheses, open parentheses, 2 star pi star x, close
Yeah.
parentheses.
Mm-hmm.
Is there supposed to, because when I did it, it shows error using the star.
Okay, does it say element by element operation?
It says incorrect dimensions for matrix multiplication. Check that the number of columns in the first matrix matches the number
Okay.
of rows.
Yeah, okay, that's going to be why. So I'll discuss that right now.
Okay.
So I know not everyone is done, but it's probably because a lot of you have the same issue. All right, so there's the code there. So let me clear everything here. And then I'll show you how to type out the exponent right now, or the exponential function. So we're going to do x equals 0. We want a step size of 0. I said 0.5, so I'm going to do 0.5. Okay, and then we're going to suppress that. And then we want to define the function y, so y equals. So for the exponential function, you're going to type exp, and then you're going to use parentheses. So exp of x. And then you'll see here, I put a period before the multiplication sign. So I'll address that in just a second. Then we're going to do 2 times pi times x, and I'll suppress that. So I'm assuming a lot of you just used the multiplication symbol here. But because we have a function cosine here, we have to do something that's called element by element multiplication, which will be talked about in chapter 2. So this part, it's not going to be on the quiz because we haven't talked about that yet, but that's why. So you can't do regular multiplication for this kind of multiplication with this function here. So now if we make the plot x comma y. So here's our plot. I forgot to put a minus sign there. That's why it's different. Okay, we're going to do y equals e to the minus x, and then we're going to plot that. All right, so here's our plot. And again, it looks pretty jagged compared to what's in the slide. So in this case, we need to increase that step size, or increase the amount of points that we have. So we'll do x equals 0.01. That's just something I always do out of habit. And then we'll rerun y, and then we're gonna replot it. And now our function or our plot looks a lot more smooth. So yeah, it's e to the minus x. I just forgot to put that negative sign for a second. All right, so any questions on this plot? Again, this multiplication here, we'll talk about that probably next week, and that's not going to be on the quiz. So I'll try to be more specific for what's on the quiz in the email that I send out today, just so there's no confusion.
So you're trying to say if we have an exponent with the cosine or sine or tangent, we use the dot star?
Yeah, well, in this case, yeah, you would have to use that dot before the star, because you're doing e to the minus x times a function that's a trig function. So you'd have to do that right there.
What if the exponent was a positive? Would it change anything like with the
No, it'd be the same thing.
Okay.
All right, so that's it for chapter 1 now. So the main concepts, just using the command window. So that's what we're going to use for the most part in this, at least probably in the first half of the class. And then basic math operators. So just, adding, subtracting stuff, multiplying stuff, dividing stuff. Precedence for math operations. So you need to be explicit about what you want to do first. Then we talked about creating a row vector, a column vector, and a matrix. Define evenly spaced arrays or a regularly spaced array, just like we did here in this top line. We're going to be doing that very often. And then creating a polynomial and finding its roots. So that's important to know, but not the focus of the class. And then saving a workspace and creating a script file. That's not going to be on the quiz, but you do need to know how to do that. And then an intro to plotting. All right, so before we get started on chapter 2, are there any burning questions you have about chapter 1?
Can you briefly explain what a polynomial is again?
Yeah, sure. So a polynomial, that's just going to be something that's like 2x to the third plus 2x squared plus 3x plus 1. Just some function like that. Appending is in chapter 2, so we'll talk about that today. So I think I've been a little confusing on what's on the quiz, so I apologize about that, but the quiz will go over chapter 1 and what we covered today for chapter 2, and you need to know how to append vectors for the homework as well. But we'll go over that in just pretty soon here. All right, so I'm going to open up the slides for chapter 2. Okay, so intro to arrays. So chapter 2 is all about arrays, so it's going to be pretty extensive. Okay, so we already talked about, how to make arrays, at least in a basic kind of format. But an array, all it means is it's a variable that stores value. So we can have an array as a row vector, as a column vector, or as a matrix. So we're just going to be dealing with that for the vast majority of the class. So we do have different types of arrays like a logical array, a structure array, Java, character, cell, function handle. Don't even worry about that right now. We're just going to use numbers for now. So a row vector, you know how to create a row vector now. We're just going to type out our numbers that we want. You can use a comma if you want. It's going to be the same thing. And we can also create a row vector by using this colon operator, as you've been doing a lot now. Or you can use the linspace command if you don't know the step size that you have for your domain. Column vector, you know how to make that. You just have to use a semicolon to terminate your current row and then start a row beneath that current row. And you can also create a column vector in a more visual way, like you see here in the slides. Personally, I don't like doing that because it takes a lot more space on the command window, but it's up to you. It still works. All right, so some notes on a vector. The order does matter. So if you wanted to use or represent vector notation like 5i plus 7j plus 2k for x, y, and z, then your order would matter. So in this case, you just have to be consistent about the order that you have for, if the first number represents x, the second number represents y, and then the third represents z. Okay, and then array addressing. So this will be a pretty big topic today. So this will be like if we want to find some value in a vector or in a matrix, we can specify in code how to give us the output for that value, or give us the value for that element in that array. Okay, so appending arrays. This is a pretty big question that I've been getting the past few days, so we'll talk about that right now. Yeah, these notes are on Canvas right now. I uploaded them late last night, so it's under today's topic on Canvas. Okay, so we can append a row vector to another row vector to create some new row vector. Okay, so let's do this right now. Let's create a row vector called A. I'm going to use different numbers than I have in the slides, because why not? I'll do 8, 9, 2. And I'm just going to show you that output. So there's our row vector A. I create a new row vector B, like 2, 9, 0, 7, 2. And there's the output for B. Now if I want to create a new vector C that is made up of these row vectors, I can do that. So all I have to do is append one row vector to the other row vector. So I'll show you how that's done. So in this case, I could use C equals A and B. So what this is going to do is create a new row vector where it starts out with 8, 9, 2, and then it's going to append row vector B to A. So if I run this, our new vector C is 8, 9, 2. So that's from vector A. And then we appended row vector B to vector A. So then we finish off this new row vector with 29072. All right, does that make sense to everyone? Okay. All right. So you're gonna need to know how to do this for the homework and most likely the quiz as well. Okay, and then so if I did a comma, if I did C equals A comma B, I'm gonna get the same thing. So just like creating a row vector, we can append a row vector with or without a comma, All right. So we can also append column vectors to make a new column vector. So I'll do A equals 3, 7, 8, 3 semicolon, 7, semicolon 8. And I'll do B equals 2, semicolon 0, semicolon 9, semicolon 22. Now if I want to make a new row vector C, so I'm going to start out with, we'll do row vector, or sorry, column vector B this time. So I'll do B semicolon A. And now you see our new column vector C, it's starting out with this column vector B. So we're doing 2, 0, 9, 22. And then I've appended the column vector A to the column vector B. So then we're going to finish off with 3, 7, 8. All right. Okay, yeah. So this will be, I guess, put in the chat right now. What do you think is going to happen if I have these column vectors A and B, and then I use a comma to make some new vector C? Or I should say some new array C. Okay, so someone's saying 2 columns, someone's saying it'll be a row. Someone says a 3x2 matrix. All right. So if we type this out now, let's see what happens. 1 row, okay. So I kind of gave it away if you have, I don't know, good eyes. So it's a matrix. So we have a 3x2 matrix, just like Ignacio said. Okay, so I kind of gave it away because I have a capital C. So this capital C, by convention, if we are defining a matrix, we typically use a capital letter. And then for a vector, we typically use a lowercase letter. So what we're doing here, we have 2 column vectors that we're starting out with. So we have a column vector A and a column vector B. Now I'm taking those column vectors and I'm saying to put them basically side by side. I'm using that notation that we've been using for a row vector, using a comma or a space. So I'm kind of merging those ideas together with these column vectors. So we still have our column vectors here. You know, this is column vector A right here on the left, and on the right is our column vector B. I'm creating a new array, because remember, an array is just storing some, some values, and I can create this matrix C. All right, so hopefully that makes sense. We'll do another one right now. So we'll do x equals 5, 6, 7, 8, or 9, and then y equals 3, 2, 1, 0. Now I can create a matrix A by doing, we'll do y comma x this time. Okay, and that's getting a row vector because I forgot to put semicolons. I always forget that. Okay, let's fix this. X, semicolons, there we go. And then y, add our semicolons. And then we'll redefine A. All right, so we had a column vector x, and we had a column vector y. And this time I wanted to put the vector y first. And then the column vector x last, so we get, in this case, a 4x2 matrix. And then you can look at the size. So we need to do size of A. And that's going to tell us we have 4 rows and 2 columns right there. Okay, so.
Excuse me, Professor, real quick.
Mm-hmm.
If you were to do x, y, would it still be 2 columns, or would that be a row vector?
It will still be 2 columns, so let's do this right here. We'll do x. Oh, I cleared everything again. Okay, let me load it back up. So if I did x comma y, it's just switching that order of which column vector appears on the left.
Okay, and if one of the variables or one of the variables had one other number, would it still work or would it not?
That's a good question. Let's do that right now. So I'm gonna change vector x here. Okay, so I'm gonna add another number there. Sorry, vector y. And then vector x, I'll keep the same. Okay, so now if we'll do b equals y comma x. And now I get an error because, yeah, they're not the same length. So in this case, they do have to be the same length because MATLAB, it doesn't know what to do if they're not the same length because it's missing a value to construct this matrix. There's nothing there. There's no number there, so it can't do anything.
And sorry, another question. If we were, let's say, if we have a huge amount of valuables for a huge collection in one of the variables, would we have to type it all out, or is there a shorter way of putting all of that into the variable?
If you were creating it, then yeah, you'd have to type it out, but you know, a lot of the time you'd be actually importing that data, and then you could, you know, let's say it was from Excel or something, you could import that data into MATLAB, and then you could assign it to some array, and then you wouldn't have to type it out. But if you were creating it yourself, kind of like we did here, then you would have to type it, all of it out in some vector like we did up here.
Okay.
Okay, so let's do this now, this exercise here. So what do you think will happen if we define these row vectors R and S and then we try to append them using a semicolon?
2x4.
2x4? What does everyone else think in the comments?
Yeah,
Maybe you already did it.
I would say 2x4.
2x4? All right, let's find out. So I kind of gave it away again. I'm using a capital B. And yeah, we get a 2x4.
So,
right.
How come this one is 2x4 and the other one is 4x2?
So for this one, I defined row vectors in the beginning. Last time I defined column vectors.
Oh, okay.
Instead of using a comma, use a semicolon for this one.
Oh, okay. Thank you.
Yeah. Okay, and then again, just like we did last time, we could do size of B if we want to look at the size for this matrix. And then, yeah, it's a 2x4. So the first number, that's always going to be the rows, and the second is going to be the columns. So you'll often see called m by n if you haven't taken linear algebra yet. So M, that means the rows, then N means the columns. All right, so far, a one-dimensional array, that means a vector. There's only one dimension to it. A two-dimensional array, that's going to be a matrix because we have rows and we have columns. Okay, so we can also create a matrix here by typing out basically row by row. So we can do 3, 2, 4, and 8, 7, 6, and then we're going to use semicolons again. 9, 2, 3. And here I'm creating a 3 by 3 matrix. So I defined this first row, then I used a semicolon, so now I'm going to start in the second row to find a row vector there, or I should say just a row. And then we used another semicolon, then we made the last row. Okay, and then again, I used a capital letter because I'm denoting a matrix. Okay, so we can create a matrix more visually, just kind of like we did with column vectors before. So I can do B equals, and then I need to start it with a left bracket here. But I can press enter right now, and now it took me to a new line. So I can start typing stuff out here. Do 3, 4, 6, 7. Use a semicolon. Actually, I don't even have to. I think that's in the next slide. Yep. So I can put a semicolon here if I want for me visually, or I can just leave it alone and go to a new line. 2, 3, 4, 9, sure, and then 1, 2, 8, 0. And then I can close it out with a right bracket. And then I created this matrix B. So in this case, it's pretty visual, so we can see specifically what kind of matrix we're making. Because, up here on the top, it might be a little harder to visualize at first, but of course, if we don't suppress the output, we can see what that matrix is that we just created. Clear this, okay. All right, so let's look at this slide now. So we can also create a matrix in a different way. So this matrix here, we just defined that matrix A. So let me pull that up again. So what we did is we defined essentially 3 row vectors. And you can kind of think of it as we appended 3 row vectors in one line of code. So I have our first row vector here, and I have the second row vector, and then I have the third row vector. So we started with the first, and then we just went down. So if I tried using that kind of same logic, but instead, let's say I wanted to do column vectors first. So if I try to make a column vector for 3, 8, and 9, and another one with 2, 7, 2, and then another with 4, 6, 3, if I try to use that same logic, I'm going to get an error. So let's do this right now. So again, I'm trying to make the same matrix, but using column vectors. So I do 3, semicolon 8, semicolon 9. And then I can do like something like a comma here. I can do a comma or a space. 2, semicolon 7, semicolon 2, comma 4, semicolon 6, semicolon 3. And if I run that, it's going to give us an error. So MATLAB can't really handle this kind of formatting. So instead, what we have to do is use this formatting below here. So we have to kind of wrap each column vector that we want to put in our matrix in its own bracket or set of brackets. Okay, so I'm going to define it as this. Okay, so I have a left bracket and a right bracket surrounding the entire thing, and that's to make the matrix. And then individually, I have brackets that surround each column vector that we want to put in our matrix. So we have 3, 8, and 9 for that first column vector right here. And we have 2, 7, 2 for the second one, and then 4, 6, and 3 for that third one. Now if I run this, then we do get this matrix output. Okay, so if you wanted to find column vectors instead of row vectors to make a matrix, you'd have to do it like this. So personally, I like doing row vectors like we did up top here, just because it's less stuff to type out, but it's up to you. In fact, I don't think I ever even defined a matrix this way, defining column vectors until last night. So I don't know, people don't do it that often. All right, so the transpose operation, this will be, again, something that you need for the homework and probably the quiz. Okay, so if you took the linear algebra class, you should know about the transpose operation. But if you haven't taken that class, basically what it does, it swaps rows and columns for a given array. So let's look at how this is done. So we'll have some array A, the 20, 30, 40, minus 2, 9. All right, so there's our vector. This is a row vector A. That's 20, 30, 40, minus 2, 9. Now if I use the transpose operation, which is one single apostrophe, it's going to transpose our vector. So it's going to take this row vector and it's going to make it a column vector now. So I can do, I don't know. So I'm going to make a variable called transpose, and then I'll use the assignment operator as A apostrophe, and that's going to transpose our row vector. And that's exactly what it does. So it took our row vector here, and now it made it a column vector. Okay, any questions on transposing?
Did it change it because you typed transpose or because you put a apostrophe?
Just because I put a apostrophe. So if I just type in a apostrophe, then it's going to transpose it on the fly. Or I can do just some other variable here, like b equals a apostrophe, and then we get the same output.
Thank you.
Are
Okay,
we gonna try to like transpose one matrix but keep the other one the same?
Yeah, we could transpose a matrix as well. That'll be a bit later on.
Okay.
Okay, so we can also transpose a column vector. So if I have some column vector b, we'll do 3 semicolon, put a bracket in here. So b equals 3 semicolon 2 semicolon 9 semicolon 0. So that's our column vector. I can transpose that to be, I don't know, we'll do e equals b, and then we're going to use that apostrophe. And now it's a row vector. So do you mean how to make a column vector, or transposing a row vector to a column vector?
Question, Professor. Is it possible to transpose two row vectors at the same time, or does it have to be one at a time?
So do you mean having row vectors like in a matrix, or what?
Yeah, essentially. So essentially, like, you know how a row, you have one row and then a certain amount of columns. Is there a way that you could, or is there a way that if you have two rows, that you can make both of those columns at the same time, like in one go, instead of doing it separately one by one?
Okay, so if I have some row vector here, like 12, 9, 3, I just want to make sure that I know what you're talking about. And then do 12, 0, 2, sure. So you want to know if I can transpose both of those at the same time individually, like still?
Yeah.
Okay, yeah, I can do that. So I can just do a apostrophe, and then I'm going to have to do a semicolon here, and then b apostrophe. Okay, so actually, I guess you can't. I thought you would be able to, but I guess you can't.
Okay, thank you.
Because a lot of the time what we can do is we can do essentially two operations on the same line, but you would have to end an operation by using a semicolon. But in this case, it's not letting us do that.
So what if you had like a 2x3? Would you be able to do that?
So a matrix?
Yeah. Like
Yeah, we can do that. That'll
so-
be, you know, you can just do that by yourself, but we're going to go over that in a bit later on. So there's a question, will putting the apostrophe just change it to its opposite form? So I wouldn't really use the word opposite because if we have a matrix, there's not really, I wouldn't say it's an opposite form. So we have a matrix, it's going to swap all of the rows with all of the columns. So since we keep talking about matrices here, we'll do that right now. So we'll define a matrix here, like 3, 0, 3, 2, 7, 8, and we'll do 9, 9, 0, 2. All right, so this is our matrix right here. So if I do the transpose operation on this matrix, now it swapped all of the rows with all the columns. So let's look at its top row here from our first matrix. So now it used the transpose operation. So now this first row is instead this first column right here. The second row is now the second column, and then the third row is now the third column. Or you could think of it, if you want, the first column is now the first row, the second column is now the second row, and then the third column is now the third row. All right, does that make sense?
Yes.
All right. Okay, so let's go on here. Okay, so we're going to have this exercise right here. So how can we create this following matrix A? So you're going to define these row vectors, and then you're going to make this matrix A. So you might need to think about this a little bit. Okay, I'll give you a few minutes, and I'm going to make a poll again to... Actually, yeah, I'll just give you a few minutes because class is almost done. So there's also a comment about making a matrix with column vectors, and so we can do that. We actually did that earlier on in the lecture, so you might need to look at those slides again. So you can stay after class and I'll go over that with you. All right, I'll give you guys maybe 30 more seconds. Okay, you figured it out? Okay. All right, so I'm going to show you guys how to do it. Was anyone able to make the matrix A without looking at the slides?
Yeah.
Yeah.
Cool. Nice. All right. All right, so if you couldn't, I'll show you what to do though. So all we have to do is append these matrices. You can do it a few different ways, but this is how I did it. So we appended append the vectors. So we appended the vector S to R, and then we also transposed both of them. So we have R equals 3, 4, 5, 6. And we have S equals 2, 0, 2, 4. And then all I did was A equals, so just on one line, we're going to transpose the vector R. And we're also going to transpose the vector S. And then I'm using this comma here to kind of put them side by side. So if I do that, then we're going to get this matrix now, A. All right. So we're pretty much out of time. So I want to finish up by saying we're going to have the quiz basically up to this slide right here. I may or may not have this as a question on the quiz, but you should study this slide just in case. So I'll also put this in an email just to make sure that there's no confusion on what's going to be on the quiz, because I think that's been kind of vague. So the quiz will cover anything that's on the homework and anything that we covered in class for the slides covered up to right now. So up to slide 18 for the second set of slides. And yeah, I'll let you know when I change the format of the homework. So what I'll do now is I'm going to change that format right now after class. I don't know how long it'll take, but I'm going to work on that. And then I'll send out the email saying that I've updated the format, and I'll let you know explicitly what you should study for the quiz. I don't want there to be any confusion. So are there any questions I can answer?
Yeah, this is just about the homework, because I was also having trouble with 4C as well. And so you said, like, in order to create the matrices, we have to type out everything. So in this case, would I have to type out everything from like 100 all the way to negative 100? Would I have to type it all out? Or is there a simpler way of compacting that?
So it was 4C you said?
Yes.
Okay, so I see what you mean. So yeah, we have to generate a vector x and then generate a vector y. So you can use the methods that we've gone over in class to generate those vectors. So I'm not going to give it away now, but it's either using that colon operator to make some domain or use the linspace function.
Okay. I think what we went over today, I think that was the part that was missing in order to do this problem.
Okay, yeah, for appending those vectors.
Yeah, because I was reading the slides and it said, m is the amount of rows, and in this case 2 would be the amount of columns. So I need to find a way in order to get 2 columns, but a specific
Yeah.
set of columns, but a multiple number of rows.
Mm-hmm. Yep. Yeah, so our rows here, they're going to correspond to the length of x and y, and they should be the same length.
Oh, okay. Okay, thank you so much.
Mm-hmm. Oh, I'm not sure if I talked about this for everyone that's still here. So there was a mistake on the homework. I think when I first posted it, I had this as y equals positive 7, but the answers here correspond to y equals negative 7. So I've updated that on Canvas. So it should show y equals negative 7 now. All right, so that's all I have for today. If you have any more questions, feel free to ask me, but I'll see you guys next Wednesday. And remember, we have the quiz next Wednesday at the end of class on Canvas. It's going to be timed, and there's no class on Monday. And homework is due on a Monday by 11:59 p.m.
Okay, so just to make sure I understand this, homework due 11:59 on Monday, quiz Wednesday at 11 a.m.?
Yeah, at 11 a.m., yeah. And I have that on the calendar as well, so you should be able to see that for this class.
Okay, so would class end a little early, or would we be doing it during class?
I'll give you the options. I'll talk about it more on Wednesday, but basically if you want to stay on the Zoom call, you can. So if you have a question, you can ask me directly, and send me a direct message so you don't disturb everyone. So you can either stay in the call or you can leave the call if you want. It'll be up to you.
Okay. Okay, thank you, Professor.
Mm-hmm. All right, any other questions? Yep, have a good weekend, you too.
For the quiz, do you know roughly like how many columns there will be?
Not really. Probably maybe like 5, but it's hard to say because there'll be like a kind of sub problem. So I might have you define some vector x and then define a function y equals like 5 times sine of x and then plot it.
What
But
happens?
I'm trying to do around 10 to 15 minutes for the quiz.
What happens? So for me, I made my desktop, and my desktop tends to do like the blue screen, not the blue screen of death, but just the blue screen. It just it notified me I need an update.
Yeah.
What happens if like my computer not crashes, but like turns into like a blue screen, which has to reset? Like what happens where technology gets involved and my system has to reset? Like would I still be able to get into the quiz to like continue the time, or once I'm backed out, like it's gonna lock me out?
Well, first I'd make sure that you have all the updates installed. But if you do run into some issue, like if your computer all of a sudden says, sorry, you got to update and I'm not going to do anything to stop, or if your internet goes down, whatever the issue may be, send me an email and then, basically I'll help you out with that. You're not going to get marked down. You'll probably just not get points for this quiz, or probably that case. I don't want to make a new one for each student that had an issue because that would take too long, but it'd be like you just never were taking this quiz.
The reason I asked is because when I was taking thermal, our professors allowed us to have like an exam for like the whole week, and it came to a point.
Wow.
Yeah, but it was like 15 palms. So 2 hour, like an hour and 15 minutes for 15 palms is kind of like crazy, especially with online.
Yeah.
It got to a point where my computer crashed, and but I didn't have to worry about it because I could go back into it without getting disqualified with points and stuff. I just didn't know because like we are dealing with technology, and technology is very unpredictable with losing internet or blue screen or all that stuff. So it was more of like precaution wise.
If you have any issues, then let me know. I'm not gonna mark you down and say tough luck.
Yeah,
I do want to have these. I don't want to have exams. I already mentioned that before, but I do want to have quizzes to kind of make sure you're up to date on your knowledge. And I know it's not ideal, but I'm having them be timed to basically encourage you to work on your own and try to make it harder for anyone that wants to cheat. Hopefully no one even does, but I just don't want to give you that option to do that.
Yeah, I understand. Yeah, I know something with my thermal, I had to do a screenshot of what was happening of it, just to like kind of balance out, like, oh, this kid wasn't lying or this guy wasn't making up. Actually, it did happen, and then it shows like my name and then like the screen on it. So it's more just assurance. In a way.
Yeah. And David, so on Monday, I technically don't have office hours because campus is technically closed, but if you do want to talk on a Monday, then we can schedule a meeting and I'm fine with that. So just let me know the time you want to meet if you do, and then I can meet up with you.